So in this video we are going to see the next numerical based on the Alembert principle. So the question is, determine the acceleration of bodies as shown in figure. The coefficient of friction is 0.2 at all contact surfaces. So these are the two bodies, 300 Newton and 200 Newton. It is connected by a single rope, and the given data is the coefficient of friction, that is 0.2. So mu is given for all contact surface and it is 0.2. Now we have to draw the free body diagram of the first. Always take the block which is resting on the horizontal surface. So we are going to solve this block 300 Newton. So we are drawing free body diagram for this block. So the self weight of the block is acting vertically downward and it is 300 Newton. Then the tension in the string, so tension in the string, it is acting towards right. So this is the tension in the string and it is denoted by T. Then next, the normal reaction is always acting vertically upward. So now the motion of block is towards right, so friction force will be acting in the opposite direction of the motion, that is towards left. So F is equals to mu into N. Then this body is moving towards right, so inertia force is acting in the opposite direction of the motion of the body, that is towards left, and this force F is given by m into A. So now we are going to apply the equilibrium condition. First equilibrium condition we are applying in the vertical direction, as the number of unknowns in vertical direction are less. So summation of vertical forces must be equals to 0. So from this we will get one unknown. So vertically upward is positive, vertically downward is negative. So N is positive, 300 is negative, so it is equals to 0. So from this we will get N is equals to 300 Newton. So this one unknown we are getting from the first equilibrium condition, that is summation of Fy. Then second equilibrium condition, that is summation of Fx is equals to 0. So all the horizontal forces we have to consider in the summation of the horizontal forces. So now towards rights are positive, toward lefts are negative. So T minus this inertia force, mass into acceleration, minus this frictional force, that is mu into N, is equals to 0. So mu is given here 0.2. Normal reaction we have calculated. T is unknown, acceleration is unknown, mass is nothing but weight divided by acceleration due to gravity. So let's solve. T minus mass is 300 divided by 9.81 into acceleration minus coefficient of friction is 0.2 into normal reaction is 300 is equals to 0. So simplifying, T minus 300 divided by 9.81 into A minus 60, which is equals to 0. Or we can simply write T is equals to 300 divided by 9.81 plus 60. By taking all these two terms on the right side, it will becomes positive. So this is equation number 1. So now we have solved the first block, that is the block kept on the horizontal surface. So now we have to solve the second block, that is on the vertical surface. Now we will find the free body diagram of the second block. So this block is not touching to the vertical surface, so there will not be any frictional forces. So let us draw the free body diagram of the second block. It is 200 Newton. So self weight is acting vertically downward, that is 200 Newton. So there will not be any normal reaction because it is not resting on the any surface. So there will not be any reaction from the any surface, or it is not in the contact of the vertical surface, so there will not be any reaction from the vertical surface. But it is hanged with the rope, so there is a tension in the rope, and tension in the rope is vertically upward, so T. But there is a inertia force, and inertia force is in the opposite direction of the motion of the block. So motion of this block is downward, vertically downward, so inertia force is acting vertically upward. So this is the inertia force, and it is given by mass into acceleration. So now we will apply the equilibrium condition. Summation of Fy is equals to 0. So we know that vertically upward is positive, vertically downward is negative. So T is positive plus Ma minus 200 is equals to 0. So from this we can write T plus mass is weight divided by acceleration due to gravity, that is 200 divided by 9.81 A is unknown, minus 200 is equals to 0. So from this we will write T is equals to 200 minus 200 divided by 9.81 into A, and we will make this equation number 2. So now if we compare the equation 1 and equation 2, so left side is T, so we can equate equation 1 is equals to equation 2, and we will solve. So after solving we will get the value of T. Sorry, here A is remaining. So we will equate these two equations. So 300 divided by 9.81 A plus 60 is equals to 200 minus 200 divided by 9.81 A. By taking similar terms on the same side, so we can solve this. So 300, so this, if we take this term on the left side, 300 plus 200, so it becomes 500 divided by 9.81 A is equals to, so now 200 is there, so 60 we will take on the right side, so 200 minus 60, 200 minus 60, that is 140. So from this we can write A is equals to 140. This 9.81 will be in multiplication, 9.81, and this 500 will be in division. So after solving this we will get A is equals to 2.73 meter per second square, and by putting this value in either equation 1 or equation 2 we will get the value of 143.79 Newton. So here it is asked to find out the acceleration of bodies. So answer is acceleration is equals to 2.73 meter per second square, and the tension in the string is 143.79 Newton. So this is the final solution of the given numerical.